Okay. Hi, everybody. As I promised you in the previous lecture, uh, I will discuss with you other 4 or 5 programs in order to understand in better depth the vision acquisition, either by using the low-level IMAQ functions or by using more advanced tools such as the Vision Acquisition VI or the Vision Assistant VI. So we begin with this virtual instrument, as you see. This virtual instrument will not open until I cancel the start video. So now I'll try to open it again. It will open, and this is the images which you see. One of them, as you see, is colored, and the other one is grayscaled. Let us discuss with you the components of the programming. So, as I said, we have IMAQ functions, open camera function, and the function which configures the grab action, and this is the grab virtual instrument. As you see, the grab virtual instrument, which is supposed to work continuously, is put inside a loop. But the other 2 virtual instruments are taken outside the loop. This makes the thing more simple, and it is not required indeed to put them inside the loop. There will be no repetition in their action. The camera, as usual, is cam 0. Here, the output of the grab function, which is image output, as you see here, is shown alone as a colored picture. It is this one. And it is taken as an input to the vision assistant in order to be processed there. So we process the input image and get at the output a processed image, which is image 2, which is the grayscale image there. Yeah, here it is. As you see, we have allocated memory area in the computer by using IMAQ create function in order to occupy this area by the array of the first colored image, and another memory area is allocated here in order to put there the grayscale image also. Moreover, the system includes a write file virtual instrument. This write file can write to required file the acquired image. So this image could be retrieved from the file with this address. It will be written in the folder called documents and has a name called Latif, and the type is BMP. But also, really, if I stop the program, you can see here by this arrow, you can select the type of the image to be written there. It should not be only BMP, it could be any type upon request. This is the iteration terminal, which stops the iteration of the while loop when this push button is pressed on. This push button is here. Also, within the while loop, as you see, there is a timer here for 1000 milliseconds, which regulates the time interval of iteration. In other words, it represents or decides the iteration frequency of the loop. 1000 millisecond means 1 second. This is adjustable. You can change it to the value you want. I'll show you now. And the last element here is the closed camera VI, which is also outside the image, outside the loop, as the configure grab VI or as the open camera. So now we know all the elements. We now know all the elements of the program, except that we do not know what I have done inside the Vision Assistant in order to get an image of a grayscale. I can open the Vision Assistant by double-clicking its icon here. Now it will open or initializes. Remember that for this assistant to work, it should be supplied or fed by the image to work on. This is the image, and it is fed to the assistant, as you have seen in the block diagram, which is the output from the grab or continuous grab function. So this is the image which is going to be processed. This is the just a reference image. What I have done, I wanted to change this color image to a grayscale image. According to Vision Assistant, I have to go to the color button here. Now it becomes blue, and select the function which I want to apply. Really, I wanted to change the type of the image from color to grayscale, so I go to this function, color plane extraction. When I press it, I press here, I have many options. For this purpose, exactly, I need to select luminance plane. Look, when I press it here now, the image became gray. I have converted the image from color to gray. And what is I am supposed to do now is to press here OK, and then everything is normal. I have already done this here, so I cancel the actions. Now you see here, this is the script diagram which shows that there is a color plane extraction. I have made that. And as a result, we see this picture here. So everything is okay. I finish and go out of the program here. And as you see, it is functioning without any problems. Again, before leaving, I want to discuss it with you to show you. Here is the first color image, and here is the grayscale image. Where it exists now, it exists now, it exists in the file which I have decided here. I must go to the documents, and there is Latif BMP. This is the documents folder. If I open it, we have to find there an image with BMP file type called Latif. Okay. Where it is, that Latif, JPG, here. We have a name continuous person. Maybe I have made something wrong. Let us go back. It is not there at the documents here. It is not in these documents, I think. I have here in my system 2 documents. No, it is here. Here is Latif, as you see. Now, if I press it, I will get the, of course, the grayscaled image. This is the grayscaled image, as you see. So it seems to me everything is okay. The system is working well, and we have no problem. We have no problem. So let us move and discuss with you another program. Let us go and see what we have there. This page is not required now. Here we discussed this program. Let us go to number 8, continuous image acquisition. Also, I open it. Okay, let us see the block diagram. As you see here is that there is no vision assistant and there is no vision acquisition VI. We are complete program composed of using or by using elementary functions. But as we did in the previous one, in order to acquire the image, we have the open camera VI and the configure grab VI and the grab VI within the loop. This is as a basis. Also, we open camera 0 as we did before. We have allocated memory area for the picture which we are going to have here at the output for the image. The image here is, as you see here, image output. I have taken it here. Here is the image which is at the output. Okay, now if we want to examine more, so the output of this grab function is taken to a write function, and we have written, as we did before, the image in a file, and this file is called continuous personal.bmp, for example. This is written in a different documents. I have 2 documents on my computer. One of them is the systems document, which is usual, and the other one I have created at the laptop here. So it is at the desktop. So this is your desktop, and at the desktop I have the documents. This is the documents, and inside there should be a continuous personal BMP image. Okay. Again, the system, of course, is stopped by using a close camera VI. And inside here, we have a timer to regulate the frequency of iteration. Of course, if we go there and look at the frequency of iteration, when I move my head, as you see, it is somehow like step change of the image. It doesn't move smoothly. This can be regulated by using or by changing the time of iteration of the loop here. Instead of 1 second, let us take, for example, 10 milliseconds. Only, which is 1/100th of the second. 10 milliseconds, 10 divided by 1000. Now, if we run the program again, we shall notice that the image will move smoothly, and you will not feel that step change. Look, as I move my head, how it is moving normally, and by our eyes, it is seen without any steps, without any stepping. Of course, you can increase the step upon request. This depends on what do you want. Maybe you want to see the image fixed for a while, so you can increase this. Instead of 1000, let us take 4000, 4 seconds. You will see that the image, as if it is stopped for a while and then it changes. If I run the program here, now I am moving, but it is stopped. Now I am changing my head. Now it changes for a while, and it takes more time and more time. It depends what is the time interval you want between iterations. The last thing we will look here is at the image itself. I said to you, it is in this documents here at the desktop. So I open desktop. It is BMP type. So I go to the file with BMP pictures, JPG, BMP here. We can say continuous personal image. If we open this one now, we shall have the last picture. It gives you the last image which we took and which was saved there. So now we have discussed another example, which I think is okay, and we are going well. So let us move forward also and try. I will exit from this file, from this image. I will not save it anyway. And let us go and have a look at another similar function for similar program, but with simple or not essential differences. I called it 8-1 continuous. Let us have a look at it. So this is also a virtual instrument in order to continuously acquire an image. If I run the program, it will take my image and it will acquire it continuously as we did in the previous program. The difference here is practically limited, but it is different kind of realization. So this is the program here. And it uses the same elements. So as you see here, this is the loop, the while loop. And inside the while loop, we put the grab function, grab vi. Before the grab vi external to it, we used a state structure in LabVIEW, which has two states, true or false. This is the true elements, the elements which will be applied or carried out when the case here, true case, is true. This terminal here decides if it is true, the whole code inside it will be carried out. And if it is false, it will not be implemented. The false case here, as you see, it contains no additional activities except passing the picture from the session from the grab configuration to the grab VI and the location of the memory for the image. So when it is activated when this terminal is true. Now, if I put here an indicator, it will be a logic indicator, of course. It is like a lamp. Let me put it nicely. Sorry. Okay. Now, if I go to the front panel, I will see there a Boolean lamp here or indicator, as you see, which is put off. It is off. It is dimmed. If it is on, it will look like this, green. So in natural state, it is off. If we go back to the program here, we say that the case structure here is enabled when this element is activated. This element activates only once when we run the program here. It is called first call element. How to find it in LabVIEW? Not difficult. You right-click on the block diagram, go to synchronization, and then you will find this first call. Anyhow, if you do not know anything about it, you right-click it and go to the help, and you will find there this first call is located in the palette which is called synchronization VIs and functions. Synchronization VIs and functions, which is here, as I told you, here, synchronization. So if you put the cursor here, you will see it belongs to this VI palette. This is the main, and this is a sub palette, which includes the first call. This is the first information we get. Then, of course, I am sorry, you can go again, and I right-click it again and go to help, and it is, as you see here, in the synchronization. And here you have some information. It gives, of course, at the output, this green light means it will give you a logic function, true or false. When it is true, the lamp will be lighted high. When it is false, it is lighted, it is dimmed. It is dimmed. So here is briefing about this function that indicates that a sub vi or section of a block diagram is running for the first time only. The first call function returns true only the first time you call after you click the run button. So when I click the right button now, I go out of it. It is not that interested for me now. When I click the run button, this will be high. And if this is high, this case will be implemented and the system will work. So it is just, it plays the role of an event function. So if I run high here, as you see, it is now high here, and the system works and it gives you images, and it is indeed a continuous image as we expected. So I hope that this is true, useful for you. Additional thing here, the system here is stopped by using only this push button, which is stop here. It is running. I stop it. It is stopped there. Anyhow, let me tell you one thing, that in LabVIEW, it is recommended always to use this stop outside and not to use the stop function, which is here. This is sometimes not recommended in different situations. This is the most common way to do it. But generally, some people are accustomed to stop the function directly by pressing the button there. It is the same. So what about this case structure? This is another case structure, and it is also put on or off by using a close push button. This close push button is also here, and it is used just to close the camera when wanted. Here, it is off, now it is on. Okay, so I think this function may add some information to you, and it is some kind of desirable repetition. Okay, I go out of it and move to another program. Don't save. So I want to discuss with you the program number 9 here. As you see, this program, this is the front panel. There is a path for an address, for a file address. And the program itself is here. What is interesting here? First of all, here we acquire image directly by using vision assistant, vision acquisition, I'm sorry. We do not need to use low-level functions directly, all the work done through this vision acquisition VI. So the output is this vision. Here is the output. But what is there? If we consider what's going, the output of the vision acquisition is also fed to a write function. This is write, IMAQ write file 2. So the image directly is written in this memory location. It is called main image, inside it is called, it is in pictures. I have put it in pictures and called it Muhammad Ali. It's my name. So if we go to pictures, if you go to pictures, This is the PC, and this is pictures. There will be a file called Muhammad Ali by my name. Let us try to find it. Where it is. Here it is. Muhammad, here is a name. If I double click it, open it by Paint, for example. Okay. It is here. So the image is already written there in the file Muhammad Ali. Okay, but now if we go to the block diagram again, so what is there? You have noticed that we have two images in the front panel and not one image. The image which we introduced to the right, VI, it has written the same image to the Muhammad Ali file. But this file is feeding the read file function. So this function reads the file directly and gives another output here. So this is the other output. So at the same time, you get the first image, you write this image to a file and read from the file the image exactly the same. It will be exactly the same. It seems to me also that this is an interesting configuration of acquiring by using Vision Assistant. Note here, maybe something wrong. Maybe here the loop condition or conditional terminal is green and the Boolean of the output is off. So if I want to stop the program, indeed, that terminal here, the loop conditional terminal, must be red. So that when I press this switch, the system will stop. Again, let us try. It is going. Okay. If I stop it, it stops. No problem. So everything is okay. Now, also, we finish with this program and move to another interesting program. Number 10. Where is number 10? 10. This is the front panel of this program. And as you see, we have two display controls. And the block diagram should have two display outputs. Yes, here is one of them. This is the acquired image by using Vision Assistant. And the output of the Vision Assistant is fed as input to the, Vision Acquisition is input to the Vision Assistant. This is very essential because Vision Assistant does not work without having an image inside it. And you can carry any processing or analysis by using Vision Assistant on that image what is inside. So this image here is expected to be the image which is processed within the vision assistant. Note here, this program is different than the one we have previously discussed, because here the acquisition is done by vision assistant, and this is by vision acquisition, and this is vision assistant. Although the program seems to be large and expanded, but really it is very compact and very short and very precise. And also, as usual, for this image to appear, we need to allocate for it a space in the computer. But for vision acquisition, it is already done by the same program here. Here, these two elements dispose the image area, I mean the memory area which is allocated for this image and for this image, both will be cancelled at the end of the program. So when I run the program, and because here, as you see, we have information given, so the program will look like this. And this is both of them, the image as the output of the vision assistant and the image as the output of the vision acquisition is the same. Why? Because we did not do anything. We stop it. We did not do anything with the image inside the vision assistant. Suppose, again, to train you more, I want to change it to a grayscale image. I have to open the vision assistant, of course. And now there should be this image. It is fed there. And from the block diagram, it is seen that the output image from the vision acquisition is fed to the vision assistant. It is existing. And now we shall work on this image, and we go to the color to change the color, for example, plane, or to extract the plane, luminance plane, for example. Look how this now, as I did before, will change. And if I say OK here, there will be an additional action in this script, which means that we have done this. And now we go output. What do you want to see? Select the outputs you want to see. I don't need to see anymore except the image output. Original image, image destination out. Here, nothing, not indicated. So I finish with this program, as you see, and this is normal. Now it seems to me, because I pressed, I didn't give it the time sufficient to compile the work. Okay, file, exit, don't save. Then I go again and open it. Yes, here is my program. And here is the images. As I told you, suppose that I want to work with the vision assistant. So I go there, open it. Okay, I have to stop the program. and then open it. It is opened, as you see. Here is the images which we did. We go back to the color. We go to plane extraction, luminance plane. It is now gray. Okay. And we finish the program. Okay. So it seems to me that this is not required. This is not required. This is not required. Don't save. So what else I want to show you? It seems that we have to look at the last program I prepared for you. Block diagram, as you see here. It seems to me the same as we did before. Here is vision acquisition, and here is vision assistant. Here is the second image under processing. Here is the image before processing. It seems to me that there is no difference between them. If we run the program here, we shall have, we shall have here, as you see, input, which is defined by an address here. Is there an address here? No. Again, back to the window block. The output must be an image, but not the apples, from where the apples come. If I run it again, I will have an output, which is, okay, the output is normal, the same, because I didn't carry out any processing here with the so it seems to me that I have previously imported by using vision acquisition the file, and this file is the output. If I go to the image here again, let us try to see inside it what we have done. Is there a file path? Yes. Here is the file path, and this file path includes Apple PG. So this was imported, and the imported, sorry, finish. We do not need to do anything with it. And the imported Apple is shown at the input of the assistant, and it has the same, of course, configuration. But if we want to change it by applying any action on the vision assistant, this is also available, as we did with my photo. Okay, so I think I have explained to you a set of virtual instruments with different configurations and different tasks by using low-level functions of IMAQ or by using express VIs. I think with this we've stopped analyzing vision acquisition. And in the coming lecture, we shall begin discussing color manipulations. How to manage colors and to change colors from a format to another format. Until then, I wish you the best and goodbye.